Hello, what's up everyone? Welcome back to a new video in developing modern apps with Azure and .NET. In the previous video, we have seen how we can query and document database, Azure Cosmos DB database, let's see, and via using the SQL version for Azure Cosmos DB. Today in this video, we will see how we can implement the CRUD operations from the .NET SDK and the .NET client, which is in this case is going to be a console.NET app. And then we will, in the next video, are going to make a full demo from backend, API, Azure.NET, ASP.NET Core, API, and the front side is going to be Blazor WebAssembly. So for this demo, what you are going to do is to simulate a case of having, for example, an app store. You'll have a set of apps. Each app has a set of properties and reviews. So we can see how we can insert new app, remove, and update, and of course query that apps. So let's get started by first creating a database here from the Azure Cosmos DB emulator, local emulator. I'll click on new database. I'll give the database ID App Store. Click OK, and let's create a new container with that. I'll click on new container. Of course, you can create a database and you can create a container from the .NET SDK, but in this video, let's concentrate only on the querying and create, update, and delete. So the container ID is going to be apps. Right now, the most crucial part of creating the container, which is defining the partitioning key. As we have said in a previous video, partitioning key is one of the main parts of the Azure Cosmos DB, because Azure Cosmos DB engines using this key to create partitions for database, which result to having or scaling that database horizontally, which means each partition could exist on a different server. So in this case, you can have somehow unlimited scaling, and in this case, it's going to increase the performance and you can reduce the cost with that. So partitioning key is the most important decision you have to take, and defining it, as soon as you have defined the partitioning key for a specific container, you are not able to change it in the future. So, and if you want to change that, you have to create a new container, set a new partitioning key, then you have to migrate the old data from the old container to the new one, then remove to the old container. But choosing the right partitioning key is going to be a good decision. So in this case, you'll save some headache in the near future, or maybe in the far future. Okay. In our case, we are going to have apps. Let's say that our app store, or giant app store, is going to contain about 1 million apps. Okay, that's a very good number. So instead of having all that apps within a single partitioning, so we can have, and of course, the number of apps could increase anytime, and maybe it could increase in a good amount. So what you have to do is to choose the right partition key. So in this case, we have every set of apps based on that key existing in a specific partitioning. So what we have to choose is, basically, we are going to have about 1 million apps, and each app is going to consist of a name, title, description, icon, the URL of the binary file, the developer information, and the reviews, but we cannot use any of those. The nice property to use it as the key for partitioning is the category. For example, you have about 100 categories between productivity apps, games, health, business apps, and education. So every set of those apps could exist in a specific partition. So this is a good decision for now. So the partitioning key is going to be the category, and we are ready to go. Let's click OK. And that's it. I'll click on apps container, then choose items. And for now, I'll just create one item just to see how our app is going to look like. So basically here I will type in a random ID, because on the local emulator, you have to set the ID. So right now the app is going to have a name, app1, description, app1 description. And we have the icon file, for example, app1 icon.png. We have cover file, cover photo, cover photo 1.jpg. Okay, we have the developer, and let's store the data of developer like this. It's going to be an object, name, developer1, URL of developer website, test.com. Then we have icon, or the logo, let's say, developer icon.png. Okay, that's good. We have the package URL, package dot, for example, rar or apk, exe, whatever. And here we have the set of reviews. The reviews is going to be an array, and the array is going to contain set of objects, name, unknown, title, good app, description, some description here, and rate. It's going to be 5 stars, for example. So here we can have good number of reviews. It's an array, so you can have whatever reviews you want. So that's good. Let's click save right now to have, okay, so the item has been generated, and this is all the details. This is how the app will look like. Basically, in the .NET, you can have you can deal with this within 2 types. First, you can create your class called an app that contains these properties, and you can have a class called developer and have a class called review. And this is, of course, the best scenario. And the second one, you can deal with this dynamically using the dynamic type in the C#. So in this case, you can have freedom of setting the properties. Of course, you won't have a strongly typed properties string or whatever. You can set whatever you want, but it's going to be a good fit for also Azure Cosmos DB, because here also you can add new properties whenever you want. And yeah, we have an important property that's added, version 1.0.0 like that. That's great. So let's move right now to Visual Studio and see how we can deal with this database from a .NET client. I'll click on create a new project, and I will choose console app.NET Core. I will call it App Store Cosmos DB demo. Click create. That's cool. Right now, the first step we should take within the application is to install the SDK of the Azure Cosmos DB. We're going to install the library, install package, Microsoft.azure.cosmos, like that. So that's good. Right now, we can go back to the Azure Cosmos DB emulator and go to Quick Start. If you are using the emulator, you can access the primary connection string from here, or if you have an Azure account and you have a Cosmos DB account within your Azure account, you can basically just go open the DB resource account resource, sorry, and then go to the keys so you can find the primary connection string here. Let's copy this one. Okay. And you should store this one in a safe place. In the real world project and in an ASP.NET project, you can set this in the user secrets on the development environment, and in the production environment, you can use Azure Key Vault. We'll talk about all of this in the future videos in the series. In our demo, we're going to store it just in variable here, but yeah, you have to keep this key in a safe place. So let's set that key here, static string, connection string. Let's paste that. That's good. Right now, let's create the client of the Azure Cosmos DB. I'll call it static Cosmos client, which is the instance I'm going to use across this demo. That's good. Here we should pass the connection string like that. And this is everything we need just to get started first. That's good. And of course, there is a database and there is a container we are going to deal with, because this connection string is referring to an Azure account or a Cosmos DB account that contains a set of databases. So we have to refer to a specific database and a specific container within that database. So what we can do is, for example, we can get that database from client.getDatabase, call it App Store database. Sorry, I forgot. If it's static database, and we have a container. Okay, and here as well, I'm going to get the container equals database dot get container, and the name of the container is apps. So in this case, we can refer to the database and container. You can also use the client here to create the database and create the container if they are not exist. But as I've said, we are going to concentrate only on the logic of dealing with the data. So that's good. Let's get started first by creating a document. Here, I will create a new function, static async, create app async. Okay, that's good. So first I will get started by dealing with anonymous objects. Then we can see how we can create a class and refer to that class. Deal with the objects from that class. But first we can deal with that dynamically using the dynamic or like anonymous object. And this is what I'm going to do. So first I'm going to create a new app. I'll type app equals new. In this case, if I don't specify the type, so in this case, it's an anonymous type. So I can type whatever I want. I'll type ID equals GUID to string name. It's going to be app2 description icon cover photo and we have the developer. We can create also another object port2 icon the URL. Okay. Now we can type here the cover photo developer. We have to set the version of the app 2.0.1 like that. And what do we have else? We have the package URL equals package.exe. Okay, we still have the reviews, but we are going to set the reviews within the update section or the update operation. But for now, this is the properties we can set. This is a great thing about NoSQL databases. You can set the properties you want in any document in the way you want. That's great. Right now, let's try to insert that into the database. It's going to be a very easy process. You can type var result equals await container. The container we have referred for at the beginning, and you can call create item async. So basically, I can pass the item, which is the app of type object. That's great. So in this case, here the result is an item response of this anonymous type. Because, sorry, we forgot a very important property, which is the partitioning key, the category, and let's say that this app is from the business category. Okay, great. So that's it. Let's call console.writeLine and you can check the result. And here we go. The result has the status code and the resource that has been created, which is the anonymous type of type, object. And we have the status code that indicates how was the problem or the operation, goes. So that's good. It's going to be pretty easy just create the client, set the connection string, fit the database and the container within that database, create object, and call container.createItemAsync, and that's it. So let's see right now here if we, okay, sorry, set console.writeLine, adding item, and we can call create app async. That's good. Let's set this one to async and change void to task. So in this case, it's going to be asynchronous. Container is an embedded between system component model and Microsoft Azure.Cosmos.Container. Okay. I will set here Microsoft.Azure.Cosmos.Container. Okay, that's good. It's pretty easy. Let's just try to start the app, but before that, let's make a read key here. Let's click start. So it tries to add the item, and the item has been created. This is the status code, and then the hello world. So the item has been added successfully. If I go back to my database here and click on refresh, sorry, I have to refresh this one. Okay, great. Yeah, I forget the category of this one, but if I click here, click OK, and here we go. This is our application, and the properties has been set successfully. It was pretty easy, right? We don't have any class, we don't have anything, and basically it's just about one line of code and it's done. It's very easy. So this is about how we can create a new item. What about updating an existing item? Let's see how we can do this by setting a new reviews for the document. Okay, I will click on region, update operation, and set that again static async. Come on, task update app async, like that. So basically the update operation is going to fetch a document, update it, and then adds and replace it with a new one. But in this case, we are going to restructure that by calling it like this. This is what I'm going to do to bring the same object, but the ID is going to be this one from that here, just to simulate the case. Okay, I will type U, which means updated, and let's set the version to 6, and let's set a review here. Reviews equals new array of objects, and within that I'm going to have a one review, name equals some user, title equals that's a nice app, there is no description, and the rate is 4 stars. Okay, that's great. Right now we have a function called within the container called replace. So we can again set result equals a container dot replace item async. This one. So it takes the item and it takes the ID of that item. So basically the item is the app and the ID of that item is the app.id, like that. So that's great. And okay. Sorry, it has ID like that. It's small letter because this is the naming convention in the Azure Cosmos DB or in JSON files in general. And at the end, we can do the same thing, result dot status code. That's great. I will comment this line. I'll type here. Again, I will comment this, call this one updating item. Let's remove this hello world from here. Now I will call await update app async. And again, let's run the application. Okay, so the item has been updated. If we go back here and click on refresh, let's click on this item, and here we go. You can see I have the new properties here, and the version should be 2.016 exactly. We have new reviews. That's great. That was pretty simple and very flexible, right? We got the document, we add the properties we want, new property, there is no structure, there is no schema. That's great. This is what I love about NoSQL actually. So, and even here we don't have description, and it's totally fine. We can query the data over the name, the title of the reviews, if there is a reviews, and too many things. We have shown all of that in the previous video. That's great. That was about update. Let's move right now to delete. So, I'm going to set region, delete, operation. Okay. Now I'm going to set async, static task, delete app, async like that. So var result equals await container dot delete item async. This one, what it should pass is the ID, and also it requires the partitioning key. So basically, let's bring the ID from here. This video I'm just trying to show you the functions and how things are going, but in the next one we are going to see how we can structure our application with an ASP.NET Core and the services repositories of the Azure Cosmos DB, so you can have a well architecture for your app. For the partitioning key, here takes the partition key value. It's called business. Here it is. Okay, that's great. And now what we have here yes, we have to specify the type of the document we are trying to remove. It's right now an object, general object, and let's type console.writeline result.status code. That's good. Again here, comment this line, deleting item, and comment this. I'll call await, delete item, delete app async, sorry. Okay, that's cool. Let's run it again. No content. Okay, let's see. Okay, because here when the delete returns no content, yeah, within the body, but as you can see, the item has been removed successfully. So those are create, update, and delete. They are very easy. Right now we have the most important one, which is querying the data. Let's create a new region, query, and region. And yeah, before we proceed, let me call this multiple times to insert multiple objects, random one. I would call for each, so I can have multiple documents to have queries on. I call 20, so add this document 20 times. Okay, start from 1 and less than 22. I'll make this one I here. Yeah, for the category it's going to be business just for now. also here the version. That's a good amount of data. Okay, that's great. So create item async, and that's good. Console.write. Like this. So let's uncomment this one. Run the application, have about 20 documents, so we can query those documents. So great. We have about 20 documents right now, exists in my database. Let's refresh. Okay, great. That's very good. Now let's move here and comment this again. Close this region and go to the query region. I will say static async. And what I'm going to use is task, sure, get all apps, or get apps async. Come on. Okay, that's good. So right now I have to type a query. For this case, of course, you can use link and you can use the traditional query, and there is also a data provider for entity framework with Azure Cosmos DB. We'll talk about this in a specific video, but for now we will see how things are going from the basics. So it's going to be select star from C, just like this. So it's going to return all the data for me, and within that I'm going to type var apps equals await container dot get item query iterator. So this one, yeah, this one is not going to be awaitable. Yeah, and it takes the query. You can pass it as a string, which is the query here, just like that. And we have to specify the type of the object that we are going to receive. Basically, we didn't create a class for our app, so it's an anonymous object. And right now, here in receiving the data, we can use the dynamic keyword or the dynamic type, which means the data will be evaluated at the runtime. We can have any property, somehow like the dynamic type here, but this type here right now, when you type app dot, it knows the properties after you created the type. While dynamic, it didn't know this. It doesn't know this in the compile time, but it's going to know this at the runtime. So it's very powerful in the case of NoSQL databases. The object and the property is going to be set at runtime. Right now, when you create a dynamic object, you can set as many properties as you want, and even if you set like the property to string, like for example, dynamic object dot id equals string, then you set it to integer, it's fine. All this issue is going to be arise in the runtime, and the data will be evaluated and resolved in runtime. So what I'm going to do, apps is a feed iterator, which means like if we click apps dot, here you have a set of properties, has more results, read next async, has more results, and yes, the one property and the main function is read next async. Basically, Azure Cosmos DB, imagine it was built for big data. Imagine here we have about 1 million app or about 200,000 app. Of course, if you call select star from container, you won't get the 200,000 document at the same time. That's going to lead to a disaster on the level of the server and on the level of the client. It's going to return this by pages. Each page contains about 100 objects, so that's going to be good. So when you have more than that number, you can call read next async. It's going to retrieve 100, 100, and of course you can control the settings of the pages. This is what we are going to see later on. By setting, for example, give every page just 10, we can get 10. We can see how we can deal in general with pages in a specific video, because it's a good topic and there are two types of that we can took, which is stateless and stateful. We'll see about this later on. For now, we can call read next async, but we'll put, yeah, we'll call it abs iterator. I'll set here abs object await abs iterator dot read next async. So this is going to fetch all the documents we have. Then we can make a for each of those data. Right now, each item is a dynamic object. So as you can see, item dot, there is nothing here. You can type, for example, dot next, dot welcome. Everything is going to be resolved at real time. So I'm going to type console dot write line. I'll type item dot name, item dot version, item dot developer dot name. Yeah, that's good. And item dot what we have category, just like this. This is great. Right now, let's call get apps async to see what we have. Comment this one. Getting items, and what you can do is await get apps async. That's great. Let's run that. Here we go. We have the app name, we have the version, we have the name of the developer, and we have the category of the application. We got the 20 documents successfully as a dynamic objects. That's great and awesome to see. This is a good point to use dynamic. Of course, if you are not familiar with this, I will put a link in the description below for the Microsoft documentation so you can read more about dynamic objects. But somehow it's clear, like all the properties has been initialized and resolved at runtime. As you can see, represents an object whose operations will be resolved at runtime. Because when you read the data, as you can see, this one becomes an object in the memory at runtime, has ID, name, description, icon, cover, developer, and the developer has a name, icon, and URL, and whatever, etc. So in this case, we can call item.name, item.version, item.developer.name, and so on. That's good. Let's see right now, what if we want to have our own object? We can create a class. Let's call it app, or let's call it store app, because app is very like generic, and I'll set the properties ID, name, string, version. Can set icon. We have cover photo. We have package. We have the developer here, so I'll create a class for the developer. Name, URL, and icon. Okay, get and set. We have also a review, public class review, and it's going to contain from something like this: name, title, description, and rate. So developer, called developer, and review, it's going to be array. You can call it reviews. That's good. This is the type that we have. Right now we still have only one thing. As you can see, when right now this data will be serialized into JSON, it's going to be in the capital letter. This is the naming convention that we use in C#, but this is what we don't want, because we need to follow this convention when we store the data and retrieve it. So to do so, I'm going to install the JSON library, install newtonsoft.json, install package newtonsoft.json. That's great. Right now we can use an attribute called JSON property. Okay, so the JSON property is ID, so you can put the names in the same naming convention in the database. Okay, so you can type them like that. Version, icon, cover, photo, package, developer, reviews. Here also you have name, URL, icon, and rate. So right now our models are ready. To use them here, it's very easy. It's not that big deal. Let's right now, instead of creating an anonymous object, I will create a new store app. That's it. We have just to set this to capital letter. So ID, just check the name. Have package URL, and developer is going to be new developer, name, icon, URL, and this one should be package URL. We need description and category. Category, that's great. So in this case, right now you have a strongly type, and you can use a create item async. It did the same, exactly the same. For the update, it's going also to be the same, but here we are still using this one. You have used, you can just translate it to the, just like the top for the delete. The delete, you haven't used it. But for the query here, yeah, the type you are expecting to retrieve is a store app. So it's not dynamic anymore. Those could be changed. You can type category. Right now, you already know how the object you will receive is going to look like. So you can use it. In this case, dynamic or strongly typed, both could work perfectly. Okay, that's great. This is the only change you need to do. Just create your classes and set the type of each method to the class you have created, and you are all done. That's it. The same result. Great. At the moment it's great. There are a lot of many things to cover, like the paging, retrieving the data in bulk, and retrieving the data using link, and dealing with Cosmos DB using Entity Framework Core. And another thing to mention is transactions in Azure Cosmos DB. All of this will be covered throughout this course, but The upcoming video is going to be a full CRUD operation. Like hopefully we'll see the schedule, what is the best or going to be a good fit for the upcoming video. And this course is going to be, I'm going to continue this course alongside another one that's going to start within 2 days, which is building a full project from scratch, like the Planner app, but this time not only client-side, it's client-side and server-side with the cloud, serverless app, using storage, using Azure Active Directory, having an ASP.NET Core API, good one with a good amount of business logic, validation, and everything you need to know to develop a full cloud solution from scratch. Just like a Planner app, it's going to be not teaching course, it's going to be a project course, or let's call it a practical course. So I hope you enjoyed this video and you will enjoy the upcoming ones as well. Thank you so much for watching and for your support. Don't forget to hit the like and the subscribe button to support us for more. Thanks again and see you in the next video.